Question 4a, 1. Find the term independent of x in the expansion of x minus 1 over x to the power 12. The term independent of x is a general term. And the general term has got this formula here. And when you look at our terms there, n is 12, r is not there, a is x, so 12 minus r, and b is negative 1 over x, and r. From here now, we first take this x in the numerator, so we have that x 12 minus r, negative 1, we extract it from the r, and then x will go to negative r. Then from there, you now put the x's together. So you have negative 1 is a constant, and so you have x to the power 12 minus 2r. The question is, find the term independent of x. So you're looking at a term whose powers of x equal to 0. So you say 12 minus 2r must be 0, implying that 2r is equal to 12, and so r is equal to 6. Then you come back and say, okay, this means that the term I'm looking for is 12 choose 6, which is r, and x, 12 minus 6, negative 1 to the power 6, and x to the power negative 6. Of course, now the x's will go. So we have just made this 12 choose 6, because again, the negative 1 power 6 becomes 1. So you simplify this 12 factorial all the way up to 6. 8, 7, 6 factorial. Down here we have this 6 factorial, and the other one you expand it. 3 by 2 by 1. Where is the other one coming from? Because we know that this is just 12 factorial over 6 factorial, 12 minus 6 factorial. So we'll have another 6 coming from the 12 minus 6. Then this 6 factorial here goes with that one. Then 6 and 2, they will take away the 12. 5 will reduce 10 to 2. 3 will reduce 9 to 3. 4 will reduce 8 to 2. So now we have remained with 11 by 2, that is 22, by 3 by 2, 6, 6 by 7, that's 42 over 1. So 22 by 42, which you can easily calculate, you guys, and that becomes a solution. That becomes a term independent of x. This is at least, that's the beauty about the exam. It has both hard things and simple things. So you go for simple things. Why stress as if the odd is all yours? 2. Use binomial expansion to express 1 over 1 minus 2x as a series up to and including the term in x3, and then state the range of validity of values of x for which the expansion is valid. This is the same as 1 minus 2x to the power negative 1. But this is, you use that expansion for any. So you have 1 plus n is negative 1. So what I'm going to use here is, if we have this to the power n, we say 1 plus n ax plus n minus 1 over 2 factorial ax squared plus n minus 1 n minus 2 over 3 factorial ax 3. So our n is -1, so just substituting. And then -2x plus -1, -1 minus 1 over 2, -2x squared plus -1, -1, -2 over 3 by 2, -2x 3. This becomes 1 plus 2x, and this is -2. This is +4 from the brackets there. So this 2 and then -2 go. So we have -1, +1, and then the 4 remains. So we have +4 x squared. Then this is -2, this is -3. So 3, 3, 2, 2. And then the negative remains. But from here, we get -8. So the negative now goes. So we have a plus. So we have +8 x3. So I have reached the term in x3. So what do you do it now? Now we say, okay, the range override it, we go back to that thing we have taken the brackets and get the one that is with x to be less than the first one. This is the same as this, where the -2 becomes 2. This is 1. And then you divide by 2, divide by 2. So this is less than half, which I can write as this if I want. Okay. From there, we have answered that part. Then we are told, using part 2, find the approximate value of 1 over 0.98, giving your answer correct to 5 decimal places. This means that we get, this is the same as this to the power -1. So we get 1 minus 2x and equate to this. Then so for x. So we have -2x is -1 plus 0.98, which is 0.02. So we have -2x is -0.02. Divided by -2, divided by -2, we get 0.01. So in our expansion here, where there is x, we must get, so we are saying this is the same as 1 plus, where there is x, we put this, where there is x, we take this, and where there is x, we take this. This is just 1 plus 0.02 plus 4, 0.1231 plus 8, 1, 2, 3, 4, 5, 6. So you have 1.02 plus 0.1234. 1, 2, 3, 4, 5, 8. 5 decimal places means 1.02040. So to be 1 0, 2, 0, 4, 1 when we round off. That is how we answer A. You just need a bit of revision. Then you are set to go. Questions? No questions? Okay, we can move. We move to B. Yeah. Okay, this one is there in the exam. I saw it in the dream. This is 3, 2x squared px minus q. It is divisible by x minus 1. So equate it to 0 and get the value of x. Then quickly bring it here and get to 0 because you've seen the word divisible. It is divisible. So the remainder is 0. And it leaves a remainder of 10 when divided by x plus 1 is 0. So x is negative 1. Come here. This must be. That's how we get the remainder. Okay. So now what is P? What is P1? P1 is you take one where there is x. So we're going to get 3 minus 2 plus P minus Q is 0. P negative 1, that is 3 negative 1, 3. Negative 1 squared. So we have negative 3 minus 2 minus P minus Q is equal to the remainder. So now what we have is we have simultaneous equations. P minus Q is negative 1 and minus P minus Q is positive 5. Okay, so from the first one, if we add these guys, we have negative 2Q is equal to 4. So that Q is negative 2. So that here we get P plus 2 is negative 1. So P is negative 3. Therefore, P is negative 3. Q is negative 2. So the equation must make sense. Yes, they do. The key thing here is being able to substitute. When it is divisible, you know the remainder is 0. When it leaves the remainder, you have the remainder. So you equate your factors to 0, get the values of x, take them in the function, and equate them to 0 and to the remainder, respectively. Then solve simultaneously and get the correct answer. I hope you get it now. Then we have B2, so this was B1. B2 says solve the equation x3 minus 3x squared plus 4 is 0. Here, the only factor I can use that can make this thing 0 easily is -1. Because -1, 3, -1 squared plus 4, this is going to be -1 minus 3 plus 4, which is 0. So -1 can be here, and then 1, -3, 0, and then 4. -3 minus 2 is -5 here. But these are negatives, and you have negative p minus q. So you have -2, negative outside, minus negative, which is fine. I don't know what you are adding. Okay, so -1 times 1, -1. You add -4, multiply 4, 4, -4, 0. So this has become x plus 1, x minus 4x plus 4. This must be the Lontia. Lontia, one is up.
Sir, I'm confused about the same question that the person was asking. Since we have -3 and -2 here, this will give us -5. And then when we take it to the other side, it's going to add with the 10, making it 15. The previous question here, when we substitute, when we have p of -1 here. Yeah.
What is p? P is -3. Is it? P is -3. Then what is Q?
-2.
-2.
That's what?
So what are we getting?
In this here.
We'll get this. Is it not supposed to be 10?
Yes, it's supposed to be 10, but it's giving us 0.
That's where the confusion is coming from.
No, here but where you substituted -1, we had -3 minus 2 minus p minus q. So -3 and the -2 are going to add, giving us -5. And then when we take the -5 to the other side to join the 10, they're going to add, giving us 15.
And not 5.
and not 5.
All right, I see.
Yeah.
No, Natasha can accept it. I thought I managed to convince her. And she just gave up.
No, I thought you at first.
See,
Yes. Hmm.
so if you add, we'll get negative 2q is equal to 14. So q is negative 7. When you take negative 7, what is q of p minus 7 is negative 1. This is p plus 7, negative 1. So p is negative 8. Okay, let's try now. Let's take in there. So we have negative 3 minus 2 minus what is p? P is 8 minus q is 7. This is negative 5 plus 15, which is equal to 10. It's okay. Now it's okay. Now it's okay. Okay. So we go back to our polynomial that we are solving for x. So this means that x plus 1 is 0, or x squared minus 4x plus 4 is 0. For 4 and 4, we have two special numbers, negative 2 and negative 2. So you get x minus 2, minus 2, x minus 2. So you have x minus 2, x minus 2. So x is 2. So you have found the values of x. You have x is negative 1 and x is 2.
So,
Hello.
if you decide to use synthetic division for the quadratic equation, how do you go about it? How do you pick the values?
You know, it's not that easy though. Sometimes, some questions is very easy, but some questions it gets complicated. But for those it has a fact, then it's okay. Because if we try, it will be 1 negative 4, 4. Let's say you want to use 2. You drop 1, then you multiply. You have 2. You add, okay, negative 2 multiply negative 4, which is 0. Then you say this means that you have x minus 2, this 2, and this one is x minus 2. Which is what we got. So it's okay.
Thank you.
It's okay. Then C is induction. So we skip. We go to question 5. Okay. Question 5. Express as a single fraction a1 as a single log 2 log 4 2x plus 3 minus log 4 x minus log 4 2x minus 1. To express as a single log, you take this there, you have log 4 2x plus 3 squared. This is dividing, this is subtracting, so you divide x also, so it will multiply in the denominator. And that's all. Well done. There's some people, this is hard to do. Then solve the equation 2 log 4 2x plus 3 is equal to 1 plus log 4x plus log 4 2x minus 1. But this, that is what we have here, which we have simplified in this form. So in other words, what we are saying is that log 4 2x plus 3 squared over x 2x minus 1 is equal to 1. Then you raise to the power. 4 to the power 1 is 4. So you have 2x plus 3. You expand and then divide by x 2x minus 1. Cross multiply, you have 4x 2x minus 1 is 2x plus 3 2x plus 3. So what you get in 8x squared minus 4x is equal to 4x squared plus 12x is equal 6. Oh yeah, 12 and then plus 9. Then you take this other side, you will remain with 4x squared. This other side you have minus 16x minus 9 is 0. So you have 4 times negative 9, you get negative 86. So to get negative 18, you use 18x plus 2x minus 9 is 0. So that you have 2x common, and you have x minus 9 plus 1. So here we have 2. So that's 2x minus 9 or 2x plus 1. So x is 9 over 2. X is negative half. This is how you pick values. Questions?
That part where equated to 1, how did you go about it?
Here, you're coming from the question. If you take this other side and this other side, your question will become 2 log 4 2x plus 3 minus log 4x minus log 4 2x minus 1. But this is what we found here in that form. So you just get it to 1 and then raise the 4 to the power 1 and simplify everything like that.
Okay, thank you.
Any other question? Test values and check if the negative won't affect anything there. Okay, so we need to log out.